Okay, so here we've got our problem. Quick recap for the viewing audience. These two lines are parallel. These two lines are perpendicular. And we're given 140 degrees nestled in that corner right there. We have to get every other angle on the page based on those two pieces of input plus the parallel perpendiculars. So, let's see what we can figure out here. From 140 degrees, if I just stay at this point of intersection, what's 6? Why? Vertical angles. Somebody else, about 5. Why? Okay. What kind of angles are the 140 and the 5? What name do they give? They're adjacent. They're supplementary. What's another name? Linear pair. And then vertical angles tells me this is going to be 40 degrees. Now, let's jump up to this intersection. If this is 140 here, what's 3 got to be?
140.
One voice, please. What kind of angles are those? Corresponding angles. And now I can use the same property to go bop and bop to get 140 from vertical and 40 and 40 because they're linear pairs. Did anybody say that angle 12 was 40 degrees because they're same side interior? 140. That's a better guess because it looks kind of like 140. The problem with this you want to be careful with is, first of all, if I look at this line and this line, I've got my transversal. 6 and 12 are technically same side interiors.
Yeah.
Because they're on the same side of the transversal and they're in the interior of the two lines. But because these lines are not parallel, all of those properties we've talked about don't apply. However, let's get 15. Is 50 degrees? Remember, we have a rule that says that a triangle has to add up to 180 degrees. So if I have 40 there at 7, 90 here at that corner, 40 plus 90 plus what gives me 180 degrees? Well, the what has to be 50. Then once I've got that, everybody else is kind of downhill from there. 15, take me over to 13, that's by vertical angles. Linear pair tells me that 12 and 14 are both 130. And then because these are parallel lines cut by a transversal, I can transfer corresponding angles and the alternate exteriors and all that other good stuff over here. And last but not least, 16 is 90. The thing with this is you had to remember that a triangle adds to 180 degrees in order to correctly transfer from this area over to here. You also want to watch your language, because a good test question might be which of the following terms applies to angles 2 and 9. And I could say same side interior, and that does apply if I consider this line here to be the transversal and these to be the two lines that it intersects. So again, you want to watch out for how these things work into what we're talking about. 2 and 9, because to be exteriors, they have to be outside the space between the two lines. So I'd have to find two lines. Yeah. Okay. I want to keep talking, but that's all I need. That's all I need. I could also talk about 2 and 8. They're alternate interiors. Because here's the line. They're on different sides of it. And they're in the interior of these two.